Okay, here's your final example, example 3 on solving with systems of equations using substitution. So if you remember in the first video when I explained what the solving by substitution is, I said that we always wanted to first get one of the variables by itself. And we always want to pick one without a coefficient. Well, if I look at this equation, or these two equations, notice that x has a coefficient of -1, this y has a coefficient of -7, -4, and -14. So both x's and both y's have a coefficient here. If you also remember from the first video, I did say that there would be certain situations, one in particular, where coefficients are okay. -1 is one of those coefficients that's okay. So what I'm going to do is I'm going to go ahead and choose this to get by itself. The reason that -1 is an okay coefficient is because everything is divisible by -1. It's not to say I can't do it without coefficients. It's just that when they have coefficients that everything's not divisible by, it tends to create fractions. So I'm going to go ahead and have equation 1 and equation 2, and I'm going to take equation 1 and I'm going to start by adding 7y to both sides. So my equation 1 is now -x equals 14 plus 7y. Now I'm going to go ahead and divide by that coefficient of -1. Please remember that when I divide the left side by -1, both terms get divided, giving me -14 minus 7y. Now that I know what, so again that's still equation 1, now that I know what x is in equation 1, I'm going to take that quantity and I'm going to plug it in for x in equation 2. And my equation 2 then becomes -4 times, again I have to use parentheses, then now that x has become -14 minus 7y, I'm going to keep the -14y and the equals 28. From here, I'm going to go ahead and I'm going to distribute. So now it's just an equation with one variable. It has only a y variable as opposed to two different variables. So distribute the -4. -4 times -14 is a positive 56. -4 times 7y is a positive 28. Y minus 14y equals 28. I notice that here on my left side of my equation I have a positive 28 and a -14. Those add together to be a positive 14y equals 28. I'm now going to go ahead and get rid of this positive 56 by subtracting it. And I'm left with 14y equals 28 minus 56 gives me a 28, gives me -28 back. Divide by 14. And I get y equals -2. Now that I know what y is, I have to go back and solve for x. Notice I have equation 1 or equation 2 to choose, and I can choose any form of equation 1. Well, I'm going to go ahead and choose this form since the x is already all by itself. And I get x equals -14 minus 7 times -2, which gives me -14 plus 14, which gives me 0. Hey, 0 is a number. I'm okay with it. A lot of times I have students freak out and go, it's 0, now what do I do? Well, 0 is a point on our x and y axis, or our x and y coordinate system, right? It's right at the origin there. So I'm going to go ahead and say that my point of intersection is 0, -2. So if I were to graph these two equations and look at where they intersected, it would be at the point 0 down 2. And that is your final example on solving using substitution.